Hi, in this video I'm going to talk about some additional concepts that are important to solve problems using the standard normal distribution. The first one is how to convert any variable into a standard normal variable, which is a z-score. Again, as a reminder, the standard normal distribution is the distribution of z-scores. So you can turn any variable into a z-score and then you have the standard normal distribution. Okay, so let's see one example in MindTap Chapter 6, Exploring Statistics, convert a value into a z-score. We saw this applet into in the previous video. Okay, this one is discover. Okay, so it's this one I showed you in our previous video, and I'm not going to spend too much time on this one again, but just to remind you, we have the number of miles for the Greer Tire Company with a mean and a standard deviation, and then we can turn, let's say, a car with or a tire with 40,600 miles into a z-score of positive 0.82 by using this formula here. Okay, so this is what we do. We turn regular like variables into z-scores, and if we plot them, we have the standard normal probability distribution. Remember the class size example we had in chapter 3. We have classes with positive and negative z-scores, classes with size higher and lower than the mean, okay? And this is important to understand the relationship between standard normal probability distribution and probabilities. So z-scores are associated with probabilities. Z-scores close to 0 have higher probabilities, higher areas, bigger areas. Z-score is smaller than -2 or and higher than +2, which means in the tails, have lower probabilities. Let's take a look here. Deviation, let's see if this one does the job of showing you. Okay, no, this one we saw before. No, useful z-scores probability. Let's take a look at this. Okay, so what I'm telling you is z-scores is smaller, lower than -2, let's say -1. Oh, I'm sorry, -2.5. is a very small probability. Look, the size of this probability, very, very small. The probability of having, the interpretation is the probability of having a number that is lower than -2.512 is very small. Okay? So a z-score is lower than that. The probability is very low, very unlikely. That's what I'm talking about in this slide. Z-score is smaller, lower than -2, or higher than 2 have lower probabilities, very small probability. Okay, the opposite would be true, like a number that is higher than 2.17 would has this small area here, which is a small probability. Okay, so that's the idea. The idea is that you look at the z-scores and see if they're smaller than -2 or higher than 2. You know that they have lower probabilities. If they're close to 0, like 0.3 or 0.6, they have higher probabilities because they are close to the center. Okay, this is what I showed you. And the takeaway, a z-score gives a probability And a probability also can give a z-score. We're going to interchange, we're going to play with the z-scores, finding probabilities, and from probabilities find z-scores. They are the two sides of the same coin. Okay.